Hello everyone, I'm Ettore, and today I interviewed the Nine Association from the Politecnico of Milan. Could you please introduce yourselves?
We are Nine, acronym for Nanoscience Innovation and Nanotechnology Engineering. It's an association from Politecnico di Milano, as you say. It's a new association, so this is our second year of life. And we basically organize events about nanotechnology, like applied in different fields. We have these like seminars and webinars, and we invite, startups or professors, other people who have a topic about nanotechnology in a certain field, which can be, medicine, biology, like aerospace, whatever, environment. Our associates can participate in these events and can learn more about nanotechnology.
Besides what Martina has said, let's say that Martina is our president, so she represents the association. Our main objective is to broaden the horizons of people that are interested in topics regarding nanoscience, nanotechnology, for them to see new applications, new fields that are still in early stages of research. And so our aim is to develop a culture among students and participate in the development, in the evolution of the industrial sector with these new technologies.
We are also to develop a network, like with partnership with companies or this kind of things, in order to have a bigger view, a more global view about nanotechnologies, because in Italy there's not a strong attention about nanotechnology. So we want to give our associates a bigger view.
What are your team's goals?
As Martina said before, yes, and also Matteo, our goals are to gather together people from Politecnico who are interested in nanotechnology, nanoscience, and nanomaterials, whatever is related to nanotechnology, even from very different people with very different background, since we have engineers from the course of nanotechnology, but also coming from other courses, university courses. Secondly, the organization of events and seminars, share the knowledge, meeting people who have a big experience in this topic, like professors, people from industries, companies, and so on. And as Matteo said, share the culture of nanotechnology in a country, Italy, that is not, in which this culture is not so widespread as other, for example. But as they have highlighted, we are a young association, so we have not so many active projects because we are building them, trying to create new collaborations.
The active project right now is the Puzzle X convention that we want to go to, which is a convention about advanced materials in Barcelona, and we have a partnership with Matter, which are the organizer of this event. Not only nanotechnology, like this is more about advanced materials, but nanotechnologies are always involved in this kind of thing when we talk about advanced materials and future. Basically, it's the first time, so we have to see how many people can participate and so on.
What is the nanotechnology community in Italy?
Unfortunately, nanotechs are not that popular overall in Italy, both at an academic and industrial level, but I'd say most of all industrial. And regarding the academic level, as far as we're concerned, as far as we know, actually there are very few universities here in Italy and very few research centers, let's say, who deal with nanotechnologies in general. And regarding industry, definitely trailing behind other countries in Europe, because there are very, very few, almost none companies who deal with nanotechnology as the main core. So I'd say that in general, the present here in Italy about nanotechnologies is not that promising, but for sure the future is. In the near future, there will be an increasing interest towards nanotechnologies in general, and we are sure that Italy will definitely follow other countries in not only in Europe, but also overall in the whole world, that also right now are dealing much better with nanotechnologies with respect to Italy, and for sure there will be an inspiration for Italy in the near future. Regarding other teams, actually, as we heard from other countries, actually we are the only students association of our kind right now, the only students association who's dealing with divulgation nanotechnologies in our country on many different levels. We are not in touch with teams like ours, let's say, on a student level. But again, as we have already told you, we already established some important partnerships, and of course in the future we'll establish many more.
What do you think are the uses of materials like graphene?
Graphene is when one thinks to a nanomaterial, thinks to graphene. I think it is the most famous two-dimensional material. It is based on carbon, which is one of the most common elements. I know that based also on my experience that graphene is tried to be used and applied everywhere in very different topics. For example, the energy storage, the bio-related fields, the sensors, and catalysis, and so on. Graphene, thanks to its beautiful, we can say, physical, mechanical, electrical properties, both as a material itself and as a platform for other materials. For example, in the field of the energy storage, for example, batteries, supercapacitors, and so on, graphene and other nanocarbons like carbon nanotubes, carbon nanofibers, and so on, are widely used, at least at the research level, as agents that could improve the performance of an electrode, and so the performance of a whole battery or a supercapacitor. So, but not only, for example, also in the sensor field, graphene-based sensors, at least at the research level, I talk about the research level, graphene-based sensors offer advantages in terms of other materials. The use of graphene also in a wider commercial scale could be affordable in the next years.
Graphene is talked about for many years, so why don't we find graphene like in an everyday life outside of research?
Yes, it's known as 2004, 2002, something like this. The most important problem is that, that graphene must be produced and synthesized in a controlled way to achieve and to obtain its, we can say, exceptional properties. And obviously, if a technique requires a high degree of control, these techniques also requires a lot of cost, typically. So this is why graphene is not so common in real and practical applications, because there exist some alternatives to graphene which are not so exceptional, but maybe are cheaper, concerning the production of graphene especially.
Yes, I also think it's a matter of cost. Like, as you say, there are alternatives that we can already use, and the technologies to produce them are already known, and they have existed at the industrial level for some time. And so make like research and introduce new equipment to produce graphene and so on, it will require too much cost. And like, okay, it could give exceptional properties to the component that we're talking about. I don't know, but is it a valid alternative to what we have right now? Could be, but maybe we need to decrease the cost for the graphene production, like find a different way or a more cheap way to do it.
A clear example of the thing that is a lot talked about, but then doesn't see a strong, robust application. And this is, as my colleague said, due to production, storage, and these kind of issues. Because to make the long story short, graphene is made of a layer of carbon atoms. So you basically start from graphite. Graphite is the material that you find in your pencil, for example. Of course, you have to treat it in a particular chemical way. And from graphite, that is made of many layers of carbon atoms. You should exfoliate these layers to obtain one single layer. Extraordinary properties of graphene are usually lost when the layers become more than 10, let's say. But we should say more than 5 to be precise. And so, since it is very difficult to obtain so few layers, then the production cost and the control of the quality requires many costs. So this is why it is not so widespread.
What would be the advantages of a carbon nanotube over graphene?
They are different materials, so they are not necessarily an alternative one to the other. They can collaborate, for example, because graphene can be seen as a sheet of paper, while nanotubes are like tubes. So nanotubes are especially interesting for their mechanical properties that they show along the z-axis. So along their length, let's say. They can be involved in the same applications, but for maybe different reasons. So they have their pros and cons, one with respect to the other.
What could be the applications of a nanowire?
Nanowires are one-dimensional chains of atoms. If we stay at the atomic level, so if we have a wire which is made only by one atom, if we have a chain that is formed by one atom aligned with another atom, in this case, the application, I don't see a real application since such structures are extremely unstable. I think, for example, to carbon atomic wires, which are chain of carbon atoms. If we talk about wires, so generic one-dimensional structures, in this case we can have many applications in different fields. For example, speak again about the energy conversion, the solar cells, reinforcement of composites. For example, if we add one-dimensional structures, or if these structures are, for example, aligned in a material, they can make a sort of reinforcement to the material. But also, for example, application in coatings for different purposes, so surface treatment, restoration, and so on. So I think that the application of nanowire obviously depends on the material that composes the nanowire, since we can have nanowires made of different materials which are specific to different applications.
What do you think is the probability of a grey goo scenario?
I mean, yes, I've already heard of the grey goo scenario in the past. Actually, think it's more like a fiction thing or something similar. I mean, the fact that nanotechnologies in the future could lead to even very dangerous or even catastrophic results for humanity, I mean, it's actually quite unrealistic, in my opinion. And of course, nanotechnologies will be disruptive in the future, and they will influence heavily a lot of fields, a lot of things in our society, not just in technologies for sure, because every time there's an important technology that has been developed, that technology for sure will have serious impacts on society as well. But still, the fact that nanotechnologies may lead to a doomsday scenario is a little bit far-fetched in my opinion. And I kind of see it again as a fiction-like thing. So yeah, maybe it's a bit an overreaction in my opinion.
Do you think that it is possible to use nanostructures to capture carbon from the atmosphere?
Yes, it is. And indeed, we have also written an article about it, which is the one. And it is possible. And actually, that's been going on for a relatively long time. Like I'd say at least the last 10 years, probably a little bit more. In the last years, the last decades, metallic nanoparticles in particular, in this case, have been widely used to capture carbon. Of course, when we say capture carbon, we mean the capture of CO2, carbon dioxide, which of course is very important also for the greenhouse effect. So this is also a topic which has been getting increasing attention and curiosity in general in the last years. So yeah, in general, metallic nanoparticles are very important in this case, because based on the precise metal, the precise element that we use as a nanoparticle, we are able to capture carbon and to store it in different compounds. For example, silver, gold, and copper sometimes, and also other elements are able to give us different compounds. In this case, trimetallic nanostructures, they are to be preferred over other nanoparticles. It's just that they are simply different. They're used in a different way and to obtain different compounds. And so yeah, trimetallic nanostructures are an alternative which has become popular in this last year. They represent, yes, an alternative which is valid in order to capture carbon or in general.
Why do you want to study atomically thin materials?
Atomically thin materials are very interesting. They can be synthesized using a variety of techniques spanning from chemical vapor deposition, pulsed laser deposition, molecular green epitaxy, and so on. And it is extremely important to study them because materials, when they are reduced down to the nanoscale, so when the thickness of the material is some atoms, or even in the extreme case, one atom, the material can exhibit properties that are completely different from the bulk material. And so, for example, its physical, optical, electrical properties can be properties that are not predicted for the bulk material that we use every day, for example. Think, for example, to graphene, which is a layer of graphene is an atomically thin material, but this is not the only case. These materials can be used, for example, in thin film transistors, in electronics, in the realization of optical devices. And most of these materials, if they are produced in a proper way, show properties that can be controlled and that can depend, for example, of the number of layers. So the same material can exhibit properties that are completely different, not only from the bulk phase, but also, for example, if we have 1, 2, or 3 layers of the same material, we can change, for example, the optical emission, the band gap of the material, and so on. And so if we want to apply these materials, for example, in an electronic device, fundamental to know how these materials and these properties are.
What are theranostic nanoparticles?
They are nanoparticles which can be used for to diagnose something, but also with a therapeutic effect. We had this event with a professor from Torino. Her research group was studying these nanostructures, which basically were nanoparticles made of different shells. So we have an internal core made of metal oxide, and then an external layer made of a lipid membrane, which was functionalized with other molecules, so that these nanostructures were able to detect precise particles, like precise cells in the human body. In this case, they were basically cancer cells. How to make them? It's, I think, a very difficult process. It's a research thing. We are not allowed to perfectly know, but basically you have to make, first you make the shell, then you try to put a second layer, then you functionalize it. So I think also it's a very long process because you have to test the stability of the particle in each step. So you have to test, is this metal oxide stable? Put the lipid membrane on it, and you have to verify that the lipid membrane will stay attached to the nanoparticle, and which can be also used inside the human body. So it has to be stable inside the human body for a certain amount of time. You have to verify the precise reaction with the cells that you want. So it's not that we know precisely how to make this particle. She obviously didn't reveal our secrets to us, but that's mainly, I think, roughly the process.
The thing is that the process to obtain this particle is always very, very long and very complicated. So yeah, there are many phases and very complicated technologies behind this. So it's not an easy task to answer this question. It would take a very long time, and also researchers need years and years of practice and research in order to obtain these particles and later to functionalize them.
How can nanotechnologies be used for rockets?
This field of application of nanotechnologies is probably the most advanced one, meaning that research here is still ongoing with respect to other fields, like for example, biology or energy, where we already have some implemented applications of nanotechnologies. For example, in the event that we held last year about this topic, we saw that aluminum nanoparticles in particular can be used in the fuels of rockets. The main reason is that in this way, we are able to lower the total weight of the rocket, which of course is a big plus. And at the same time, we are also able to increase the energy that we obtain from the combustion of the fuel. This is the main trend, let's say. We can use nanoparticles in the active fuel so that we can obtain more energy with the same amount of fuel, and at the same time, the rocket itself, since the fuel is less heavy, of course the rocket will be less heavy, so its motion will be easier to obtain, basically.
Do you have any big announcements for your team?
Right now, I think we don't have big announcement to make to the community, or also because we are not trying to develop some big project, or we are not participating in events like teams. So for instance, our university has a car racing, sailing team and this thing. So they probably have bigger announcements to make, because they have also bigger projects. Dreams, I think we have them, we are a new association, so it will be useless to exist without dreams as a new association. I think that the dream is to spread knowledge about nanotechnology, not only in our course, my course, their course is materials and nanotechnology engineering, so it's inside our course, but others, they don't have it, while nanotechnology can be used in a very, in a lot of different fields. As we said, you also found articles. So we have aerospace, then we have biology, medicine, and then we have energy, environment, and so on. So there are a lot of different fields, and it will be nice. It will be my dream to make people understand that research about nanotechnology could be a huge game changer. Not only fields that you can imagine being associated with nanotechnology, I don't know, energy, because a lot of products just exist even nowadays, but also to other people in very different fields or courses, or even people who are not studying these things, but it's also, like, it's always very nice to have people realize how amazing nanotechnologies can be in very different applications. So even if they are not studying it.
The next big thing has been already announced, which is our participation to the X event in Barcelona, where we have been invited from a member of the staff of the organization. But then what Martina said is more than correct, and I agree with her. Spread the knowledge, spread an environment with the aim of one day having a community of students, of engineering students, more aware of the potentialities that these technologies have in each and every field, actually. And so that's it. This is our objective.
What are your personal plans for the future?
Here, everyone has a different plan for the future, so I speak for myself. Now I'm doing a PhD regarding nanomaterials and nanotechnology, so I would like, first of all, to conclude my PhD, because this is the most important thing. And then I've not decided yet if I prefer to studying and doing something like this in an academic go, for example, to a company. I would like to work in the fields of synthesis and the production of nanomaterials, as I am doing now, maybe also in a more industrial environment, like a company dealing with, I don't know, for example, the energy field. I would like to work.
I'd like to work with nanotechnologies applied to nanomedicine or to environment. Sincerely, right now, I don't know if I want to work at the academic level or at the industrial level. Also because nanomedicine is not very present at the industrial level. I think it's more about research nowadays, and I don't know how many companies are out there doing research about these things. About launching like my own startup, it will be very nice, but I have to have a great idea to do that. And also a very good support team there. And right now I don't have, I don't know, it would be nice, like it's a nice idea if you have your own thing, your own idea, your creativity, and you have a team to work with. But right now I don't have these things. I'm more like focused on the present. So just finish the master degree and just try to understand what you really want to do. So just work in company, academic. I still don't know about these things. So it's a very difficult choice. Also because we are in Italy. So like, for instance, I don't even know if I have to work here in Italy or abroad, and I'd like to work here. I think it will be difficult to find a good job as a researcher for this thing.
Actually, I'm still taking time to make my decision whether continuing and pursuing a PhD, always in the field of nanomaterials, especially energy production and storage field, which is my main field of interest. I'm now developing master thesis projects on electrochemical applications with using nanomaterials to produce electrodes for supercapacitors and also electrodes for hydrogen evolution. So I would like to stay in the field of new energies, in the field of sustainable development and so on. I don't know, I feel like I'll find first a job in a company and then maybe start a PhD later to deepen my knowledge and become prepared on the topic, and maybe in the future at my own company. Why not?
Do you have any questions for me?
When did you first hear about nanotechnologies in general? What is your main field of interest? For example, we see during this presentation that there are many fields, and if there's one in particular that you might be interested more into.
So I know about nanotechnology from a pretty long time, but only recently have I studied it. For fields that I'm interested in, I think that graphene is interesting, not only for its properties, but also from how long we know that it exists, but how little we've made in all the years that we know the graphene's existence.
We do have produced it in quite some quantities. The thing is, as we already underlined before, the main problem about graphene is that the technologies through which we can obtain graphene, which can be many in general, there are many possible technologies to obtain it. Each of them has its own disadvantages, and more in general, almost all of them are quite still expensive nowadays. That's the main reason why graphene is very popular at the research level, but actually not very popular at the industrial one. This is also the reason why you don't see graphene in everyday life. And this is why also you say that graphene hasn't been obtained in very large quantities. That's true at an industrial level, but again, researchers are working on improving the existing technologies to obtain graphene. with the final aim of obtaining at least one of course, most possible technologies to achieve graphene in a competitive way with other technologies relating to other materials.
Lab scale technologies are very different from industrial scale technologies. It's very difficult to apply the same method that you're using at the lab scale at the industrial level, because obviously at the lab scale you want like some samples to analyze the material, the component, and analyze its properties. But at the industrial level you don't want this. You want something which can produce a large quantity of graphene at the same time, but this will require like a superior control of the process, and I don't think that nowadays it is possible at the industrial level, but I think that they're working on it. I think that they're probably working on like an industrial scale equipment for the graphene production.
Isn't graphite made by many layers of graphene? If you would somehow be able to separate those layers, you would have graphene.
Yes.
This is how they have produced the first time graphene. So they have exfoliated a graphite, bulk graphite phase. The problem is that it's not so easy to exfoliate something which is made by many layers of graphene to obtain only one. And also another important point is the area, because this can be done with a piece of graphite which is quite small, and it's not very easy. Also using liquid-based exfoliation techniques that exist, it's not so easy to obtain perfectly atomically thin layers of carbon, so layers of graphene. It's not simple. Even if we have a lot of pieces of graphite, remove one layer by one layer, bulk graphite with a lot of layers.
Has anyone tried charging the graphite electrostatically to like 200,000 volts or more, and then seeing if like the graphene would separate if you would have like a very thin piece of graphite? Because I think that graphene is more resistant in traction and being pulled than in holding itself to another sheet of graphene.
That's right. If I understood correctly, you asked whether someone in the past obtained graphene by basically electrocuting graphite.
So if you have two charges, like a positive and a positive, or a negative and a negative, so if you would have 5 sheets of graphene, or 10, or how many it is, in your very thin piece of graphite, if you would be able to charge it to very high voltages, then you could make it so the different layers of graphene repel each other.
In principle, it could be possible. I don't know if it has been done. Actually, I don't know.
No idea.
I think that maybe it is possible, but we have to see if it is feasible. Is it a feasible technique in terms of cost, equipment? Also, because I didn't mention before, but commercial graphite typically is a disordered material. If we want to remove one layer by one layer, we need a perfect graphite that is typically the highly oriented pyrolytic graphite, which is very expensive. We have to see what happens, and if it is possible to charge with the same charge different layers.
Layers, yes.
I don't know, maybe if you got any new facts or interesting topics from this talk with us, if we, I don't know, if stimulate your curiosity in some way.
Yeah, so I had this idea of charging graphite to get graphene. Didn't think of that before. Yeah, a bit in general.
Thank you for contacting us and finding us on LinkedIn.
And thanks for being here.
Thank you.
Bye.
Bye. Bye.